Here's the basic science behind New Jersey earthquakes and the Ramapo Fault. Understanding the fundamental science behind earthquakes in New Jersey, particularly the Ramapo Fault, is crucial for residents and curious minds alike. Recently, 2 earthquakes shook North Jersey in less than a week, and it's not just a figment of your imagination. These seismic events have stirred more than just the ground beneath our feet. When an earthquake occurs, many people find themselves pondering the reasons behind it and how its strength compares to other seismic activities both in the state and globally. Let's delve into what experts reveal about the science of earthquakes. What triggers an earthquake? An earthquake is primarily caused by the movement of the Earth's tectonic plates, as explained by the U.S. Geological Survey. The boundaries of these plates are characterized by numerous faults, and it is on these faults that most earthquakes take place. The USGS notes, the edges of the plates are rough, causing them to become stuck while the rest of the plate continues to move. Eventually, when the plate shifts sufficiently, the edges unstick along one of the faults, resulting in an earthquake. In New Jersey and other regions, earthquakes typically happen when the strain that has built up slowly within the Earth's crust is suddenly released along a fault line. This information is detailed in the publication Earthquake Risk in New Jersey by the New Jersey Geological Survey. The energy released during this movement propagates as seismic waves, traveling both along the surface and through the Earth. Dr. Matthew Goring, an associate professor of Earth and Environment Studies at Montclair State University, explains that these earthquake waves are a direct result of the energy released as tectonic plates shift. The area where this slippage occurs is referred to as a fault. Among the various faults in New Jersey, the Ramapo Fault is the most prominent, extending in a northeast-southwest direction across North Jersey. Most of the state's earthquakes have been recorded in proximity to this fault. A glimpse into New Jersey's earthquake history. The Ramapo Fault system stretches from southeastern New York to eastern Pennsylvania, as noted by the Earth Institute at Columbia University. These faults have been active at various points throughout the geological history of the Appalachians, particularly during the Mesozoic era, when they acted as border faults to the Newark Basin and other extensional basins formed by the Atlantic Ocean's opening around 200 million years ago. In New Jersey, fault lines typically do not reach the Earth's surface, but are located several miles beneath it. Interestingly, earthquakes that occur east of the Rocky Mountains are generally less intense than those to the west. However, due to geological differences, eastern earthquakes can impact areas that are 10 times larger than western earthquakes of the same magnitude, according to the New Jersey Geological Survey. The point beneath the Earth's surface where an earthquake originates is known as the hypocenter, while the point directly above it on the surface is referred to as the epicenter. How significant is a 2.7 magnitude earthquake? Earthquakes are measured using seismographs, and their magnitude indicates their strength. A 2.7 magnitude earthquake, like the one experienced on August 5th, typically results in minor to negligible damage in the surrounding areas. It's important to note that as the magnitude increases by one whole number, the earthquake size increases by a factor of 10. For instance, a magnitude 5.0 earthquake would produce 10 times more ground shaking than a 4.0 magnitude quake, releasing approximately 32 times more energy. According to a report from the New Jersey Office of Emergency Management, New Jersey is situated in a region where less common plate interior-related earthquakes occur. As tectonic plates continue to shift and their boundaries evolve over time, weakened boundary regions can become part of the plate's interiors. These zones of weakness within the continents can trigger earthquakes in response to stresses originating at the plate edges or deeper within the crust. Final thoughts. Earthquakes can be a source of fear and confusion, but understanding their science can empower us. What are your thoughts on the frequency of earthquakes in New Jersey? Do you believe we should be more prepared for these natural events? Share your opinions in the comments below. 2.7 magnitude earthquake felt in New Jersey and New York area. Imagine being in the middle of your daily routine when suddenly the ground beneath your feet starts shaking. This is exactly what happened to dozens of people in the New Jersey and New York area on Tuesday at 12:11 p.m. Eastern Time when a 2.7 magnitude earthquake struck near Hillsdale in northern New Jersey. But here's the surprising part. Despite being considered a relatively weak earthquake, it was still felt by many people across the region, from Staten Island to southwest Connecticut. According to the U.S. Geological Survey, USGS, the earthquake occurred roughly 8 miles below the Earth's surface, which is relatively shallow. This shallow depth likely contributed to the fact that many people felt at least some shaking, even though the quake itself was not extremely powerful. But what's really interesting is that the unique characteristics of the rocks that make up the Earth's crust and mantle in the eastern U.S. play a significant role in how far the most intense waves of seismic energy can travel. The rocks in this region are much older, denser, and harder than those in the West, having been compressed by time. This makes them more efficient conduits of the seismic energy released by an earthquake, allowing it to travel in a more potent form over longer distances. And this is the part that most people miss, the fact that the Earth's geology can greatly impact how earthquakes are felt. For example, the same earthquake that might cause minimal damage in one region could have a much greater impact in another region with different geological characteristics. Hillsdale, where the earthquake occurred, is about 25 miles northwest of Manhattan, which is a densely populated area. The fact that the earthquake was felt in such a wide area raises important questions about earthquake preparedness and the potential risks associated with seismic activity in the region. But here's where it gets controversial. Some experts argue that the eastern U.S. is not as prepared for earthquakes as the West Coast, despite the fact that earthquakes can and do occur in the region. Others argue that the risks associated with earthquakes in the eastern U.S. are often overstated. So we have to ask, are we doing enough to prepare for earthquakes in the eastern U.S.? Should we be taking more steps to mitigate the risks associated with seismic activity in the region? We'd love to hear your thoughts in the comments. CNN's Eric Zirkle contributed to this report, which highlights the importance of staying informed about seismic activity and being prepared for the unexpected. By understanding more about the geology of our region and the potential risks associated with earthquakes, we can work together to build safer, more resilient communities. 2.7 magnitude earthquake shakes New Jersey again. Aftershocks explained. Hillsdale Update 2025. A 2.7 magnitude earthquake shakes New Jersey. What you need to know. On August 5, 2025, a 2.7 magnitude earthquake struck Hillsdale, New Jersey, just days after a separate tremor rattled the same region. This seismic event occurred around noon, as reported by the U.S. Geological Survey. And while it was felt across the tri-state area, there were no immediate reports of damage or injuries. Residents are buzzing with conversations about this unexpected quake. Jimmy, a local who lives near the train tracks, initially mistook the shaking for a passing train. There was no train going by, so clearly something happened, but we weren't really sure what it was, he shared. Although a magnitude of 2.7 might not seem significant, for many on the East Coast, experiencing the ground tremble is a rare occurrence. Teresa Alesso, a Washington Township resident, expressed her surprise, saying, "It's like a role reversal between us and the West Coast, which is kind of mind-numbing and a little concerning." This sentiment reflects a growing unease among East Coast residents who are not accustomed to such seismic activity. The recent earthquake in Hillsdale is believed to be an aftershock of a previous quake that occurred in Hasbrouck Heights just a few days earlier. Seismologist Ken Miller from Rutgers University explained, "From the work done by geologists at Rutgers, We can say it seemed likely that both of those were coming off at depth off of the border fault. The border fault runs to the west in a northeast-southwest fashion, and it runs right near Tewksbury, where the big earthquake was in 2024 in April. In fact, New Jersey has experienced a total of 17 earthquakes and aftershocks this year alone. While most of these seismic events have gone unnoticed, the last two have prompted discussions among community members about their experiences. Alesso described the sensation, saying, "Seriously, it felt like two trucks hit or it hit into the house and it was just this big boom sound." Meanwhile, Jimmy compared it to the mild vibrations felt when a train passes by. Looking ahead, Ken Miller advises that residents should prepare for more aftershocks in the coming weeks. He anticipates that most of these will be smaller than the recent 2.7 quake, with some potentially going unnoticed altogether. But here's where it gets controversial. Are we witnessing a shift in seismic activity on the East Coast? With more earthquakes occurring, should residents be concerned about future tremors? What do you think? Share your thoughts in the comments below.